The following presentation is for Nexio's BAT-EMC software. We are going to explore the manual MaxHold measurement mode. This will act as a supplement to a previous video that was done for radiated emissions according to CISPR. If we look at the data from that previous video, we can see that we have tabular data on the sections above, the graphic data down below, and in that video we were choosing 3 max peaks for each sub-range. If you look in this particular sub-range, you could see that for example this peak did not get selected. Let's go ahead and double click on that to move the cursor there, and I can also right click on that cursor and we'll say to move it to the table of suspects, and then it will appear up above like so. We could also have chosen one of the previous peaks to analyze further, remeasure it, and so forth. Let's select that peak, and there are 2 ways to enter that mode. One would be by right-clicking and selecting that mode. The other is by selecting the button. And once we double-click on the frequency of choice, then it will activate that. If you look here, once again, you have a choice of resources, but all the other ones are fixed. We will stay with the current resource. And I will deselect peak search. That can be done later. I will only focus on using the peak detector. We're going to return to the angle and height that was found when that peak was originally measured. And we are going to change the parameters to be in line with that frequency range. In that range between 30 megahertz to 1 gigahertz, the standard requires a 120K resolution bandwidth. The typical measurement time is about 1 millisecond per megahertz. We'll increase the time just slightly as far as the measurement time using the peak detector. Now I can start the measure, and then you can see the bar graph enabled up above. This is to simulate measuring continuously in MaxHold, and if there are any new maximum values, it would appear in this window here. Now, regarding the maximization effort, we can choose to go there by commanding it. For example, I can command it to go to 360. But I can also use these buttons here. While this is incrementing upwards, any new max values are going to be recorded up in this window here for the peak detector, as well as the new angle that could be found. Now we can say to go to 0, or I can also just command it to go to 0. One other thing to be observant of is the fact that yes, we chose the horizontal polarity. When this box originally opened, it was taking into account previous settings and data. Now the angle, as you can see, is still 0. We're going to leave it there. Let's experiment with the height change. I will tell it to go to 4 meters. And as it goes upwards, once again, any new max values are being recorded. We can see here that this has increased slightly. You can also see here that the height changed from slightly over 1 meter to 1.71 now. I will command it to go to 1 meter. And we can see if that will change. Okay, we can see that 1.71 definitely was the max, so I will command it to go exactly there. We've asked some customers as far as what algorithm they're using and the maximization effort, and this corresponds well. However, we have had some customers who say they would like to use the quasi-peak detector, and I had to remind them that the quasi-peak detector is extremely slow. The minimum charge time is about 1 second, and therefore we only use the quasi-peak detector for final measurements once the positioning systems have stabilized. If you were to rotate or change an antenna mast in 1 second, you could travel very far. We will also command it to do a peak search. So what that means is that if there's a new center frequency, this is centered on 265.225 megahertz, it will then find the new center and it will dwell on that for the quasi-peak detector. So we can start the measurement, but before doing so, let's set it to the actual time required. CISPR recommends 15 seconds for any disturbance which is determined as unsteady or basically uncharacterized. If it was something that was known to be steady, then we could use 1 second. We can start the measurement, allow it time to do the peak search as well as to quasi-peak, basically 15 seconds for each. You will note that the limit for that is also shown here so that we can get the right margin calculated. Now that we have completed the CISPR measurement, we can stop the measurement, and then once we say store as a final, the values are produced here. If I compare that height was 1.98, which is slightly different, and also the angle, it was in this case was 201 originally. Here the angle is 0. So indeed, doing the maximization effort did reveal a different max value. Let's close that, and then if we look, this was all the previous data, quasi-peak, peak, average, and then you can see a special table only created for the manual MaxHold measurement that we just completed. Thank you for your attention. This concludes the Nexio presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.